Welcome to episode 77 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data and AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Today's episode is about Fei-Fei Li, the visionary behind ImageNet.
Yes, Fei-Fei's work literally changed how machines see the world. ImageNet is a dataset that revolutionized computer vision and kicked off the modern AI boom.
Let's start with who Fei-Fei Li is. She's a professor at Stanford and a pioneer in artificial intelligence, especially in the field of computer vision. But more importantly, she's someone who understood early on the importance of large-scale labeled data in training AI systems.
That insight is huge. Before ImageNet, training machines to recognize objects and images was painfully slow and limited. It was like trying to teach a kid to identify thousands of objects by only showing them a few pictures each.
Exactly. Let's pause and define a couple of things for our listeners. Computer vision is the AI field that focuses on enabling machines to interpret and understand visual information from the world, just like humans do when they look at photos or videos.
And the challenge there is huge. Images are complex data, colors, shapes, textures, and deep context. Teaching a machine to recognize a cat in a photo is not the same as reading a spreadsheet.
That's where datasets come in. A dataset is a large collection of examples, like images, paired with labels, what that image represents. Labeling is the process of tagging these images with the right reference. For example, you tag a picture with dog, or car, or stop sign.
Before ImageNet, these datasets were small and often not diverse. That meant models trained on them couldn't really generalize well in the real world.
Then, Fei-Fei Li and her team created ImageNet, which consists of over 14 million images labeled across roughly 20,000 categories. It was the first massive, publicly accessible image database of its kind.
And the impact was almost instantaneous. With that much data, researchers could train deep learning models that actually worked in more varied and realistic settings. This helped AI really start to match or exceed human-level performance on certain image recognition tasks.
To put this in context, Fei-Fei Li didn't invent deep learning, but she gave it the fuel it desperately needed: vast, quality data.
Right. And from a business standpoint, that meant a jump in what AI could be used for. Suddenly, automated image recognition wasn't a pipe dream. It became possible for applications like medical imaging diagnostics, autonomous driving, and retail inventory management.
The key idea here is that data is foundational for AI. The better and larger the dataset, the more capable the AI model can become. ImageNet showed the entire AI community this in a concrete way.
I remember working with an automotive client a few years ago who struggled with their self-driving car's ability to recognize pedestrians and road signs in unusual conditions like fog or dawn.
Interesting. What was missing there?
Their training data was limited, mostly clear daytime images from calm urban streets. When the vehicle encountered different lighting or weather, the system stumbled. But by augmenting their training data with diverse samples inspired by datasets like ImageNet, they improved detection rates dramatically.
That diversity is so critical. ImageNet's breadth means models learn not just what an object looks like in perfect conditions, but various appearances, different angles, lighting, backgrounds.
Fei-Fei Li also emphasized the ethical responsibility in AI, especially around how data is collected and labeled. In fact, transparency and careful curation of datasets have become a big topic following ImageNet's success.
Yes, ImageNet sparked conversations about bias in datasets too. If the labeled images don't represent diverse populations or contexts, models can inherit those blind spots.
Absolutely. I've seen companies face criticism or outright failure because their models ignored minorities or unusual cases. They had to go back and carefully expand and balance their data, much like what Fei-Fei advocates.
Another remarkable aspect of Fei-Fei Li's work is how she combines deep technical expertise with a vision for AI benefiting society broadly. She co-founded AI for All, an initiative to increase diversity and inclusion in AI education.
That's something I really admire about her. It's one thing to advance technology, but another to ensure that it's accessible and ethical. For consultants like me, it's a reminder to guide clients toward responsible AI practices, not just flashy tech implementations.
So, pulling this together, Fei-Fei Li's contribution, through ImageNet, set the stage for the deep learning revolution by providing the massive, labeled dataset needed to train neural networks effectively.
And in the real world, that means better AI-powered tools for industries ranging from healthcare, where AI helps radiologists spot tumors faster, to retail, where image recognition powers visual search and inventory management.
It's amazing how one dataset can ripple across so many fields.
For sure. And the lessons: never underestimate the power of quality, diverse data, and always think about who's represented in that data.
Before we wrap up, Amy, what's a simple way for our listeners to explain Fei-Fei Li's impact to others?
I'd say she gave AI a pair of eyes. By creating ImageNet, she taught machines to actually understand what they're looking at. That's the foundation for all the visual AI we rely on today.
Perfect. And I'd add, her work highlights that in AI, data isn't just fuel, it's the lens through which machines view the world.
So here's your key takeaway. Fei-Fei Li's ImageNet transformed computer vision by providing massive, labeled data that enabled AI to truly see the world. Without datasets like this, modern AI simply wouldn't exist in its current form.
And from my side, when thinking about AI, always remember that theory meets practice through data, and Fei-Fei Li's work is a brilliant example of bringing those elements together thoughtfully and responsibly.
Next episode, we'll dive into Yann LeCun, a founding father of convolutional neural networks, the core technology behind how computers analyze images. You won't want to miss it.
If you're enjoying this, please like or rate us 5 stars in your podcast app. Feel free to leave comments or questions. We may feature them in future episodes.
Thanks for being here with us today.
Until tomorrow, stay curious, stay data-driven.